try to talk like this all the time, get some audio. Sorry about that not working. Yeah. Reality stars. All right. It's close to me, so it should work. If it doesn't, I'm sorry. I can re-record it for you guys. Okay, so I don't know why it's not full screen. I'm just going to do like a few minutes on slides. The objective for today is to really to do a review and spend most of the time on exercises. I have like a lot of exercises to do, and we'll do them in real time, where we write them out, without the answers there. And I'm not going to call on you guys and force participation. Just like, you don't have to raise your hand. Just if you have an idea, just suggest it. I just wanted to spend like maybe 3 minutes on a few more advanced SQL functions that I promised some of you and promised myself, frankly, that we'd get to. And the way the semester played out, we didn't really have a chance to get to all that, and we're not going to go deep into it and do crazy advanced queries, but I wanted to mention it to you. I have some examples that I'll show you here. I've made like 3 or 4 long SQL worksheets that with examples that I'm going to upload. So they're already ready with all these things. So you and a lot of links that really simply explain these things in more detail. So if you want more detail, it's there. You can always reach out to me too. But I just wanted to like very briefly touch on them. We'll go over the stuff that we've covered this semester, and we'll just do a bunch of examples. I did a play on words there, examples. Really clever. Okay, so the 3 things I wanted to just really briefly get into is case, case when, count case. Number 2, dynamic queries. And number 3, window functions, and more specifically, partitioning, which is like a very like leading edge, like not all SQLite versions even support it, way to do grouping and filtering and joining without really long queries. There's other stuff that I would like to get into, but we didn't have time for, but it's not like we've covered everything SQL has to offer. Okay, so just briefly on case when, it's pretty much like your if-then in SQL. So you're not going to see these examples really clearly, and it's okay. We're not going to go through it all. But in a case when, you could put it in a lot of places in the query and select. You can do it in order by, in the grouping, and you can specify multiple conditions. So you can have if then, but you could have if, like elif, else, like a lot of different options. You could also nest them inside each other, which I can show you an example of. I think I might have one on the next slide, where you do like when it's this, then, and then you nest it inside that. When it's that, then, and so you can have a lot of layers to it, just like an if-then statement in Python or any kind of logic. So you can do up to 10 levels of nesting. Once one of these conditions is true, like if it's like united, then that layer will stop. And it's good practice to end them with else. In case none of these hit, then you have like a default value to fall back on. So in this example, I loaded another database because some of you are probably sick of the Chinook database with the artists and the tracks and the composers. So I have a few different databases that we'll use as examples today. This is from Sequila database. It's on like movies and actors. But I just did, like I wanted to group and categorize the customers into their like nationality category. I just made it up. So people that are from the UK and the US, I'm calling Anglo-American, and et cetera, et cetera. And this is the output here. And you can then group by that case when. So I created these categories, and then I'm grouping by those categories. All right. Again, we could spend a lot more time on it, but that's not my intention today. So I mentioned case count, count case to you guys earlier when we did like count star, count distinct, etc. So I have a comparison here. This is done in Python, but same difference. So it's all the kinds of count that we covered. So on the left here, you have count star, which is going to count every row in the table, including nulls. Count age, whatever column, is going to count every non-null row, so it's going to not count the null rows. And then count distinct age is going to count all the non-null rows that don't repeat. So you see the different outputs here, and the slides are on Moodle also. So we have the star is all the rows. So we have 168, 77, blah, blah, blah. When we count just the non-null rows, we count age. We have 130, etc. And then when we count a distinct age, I'm showing you here the 3 different outputs. So it narrows it down to 58, 24, and 80. Okay, so those are the ones we've covered. I mentioned count case. Case, it's an if-then, and it's a Boolean, like a true-false. And Booleans, I think everywhere, but in Python and SQL, when it's true, it's 1, and when it's false, it's 0. So it allows you to calculate accuracy and things like that in like a efficient vectorized way, but that's what it's doing here. So it has like a Boolean, true, false, and it's counting the number of trues. Okay, so I'm saying there when the lower name, and by the way, lower is just a way to lowercase every character that's in that string, which equalizes, and you avoid the problems of a single capital letter in a name. So when the lower name is like Mr., and I have the wildcard with the % sign, because it has Mr. somewhere in it, then 1. Okay, so I'm giving it a 1 or true every time it has something like Mr. in the name, and then I'm counting all those instances. So you see I have the passengers, the count star, that's the same here, and the number of Misters, which it's still grouped by embarked, which is whatever, a code for when they embarked, and it counted the number of times within each of these groups that I got a true for that condition. Okay, so that's count case. Like if you're doing like a if-then or true-false on a lot of records, and you want to count the number of trues, count case. Yeah. This is from like a bunch of like more advanced SQL queries I did within a Python environment, and you see it's like in quotes and uses pandas to output. So you're right. Like it's tough to appreciate this until you use different ones, but each like engine and user interface is going to have different like quirks and different syntax a little bit. But yeah, the one that we covered with DB browser is not null, is the right way to do it. And DB browser let you get away with like a lot of different ways to do things. So that just further complicates it, but big catch. Okay, so this one I'll really spend like 30 seconds on, because I don't want to go down the rabbit hole. But it's pretty cool. Dynamic queries. It allows you to do a query where the condition that you put in can change whenever you want. So without rewriting the whole query. And without going into it, you guys will have this example and links and other query examples in the notebooks that I share. Without like really getting into it, we just have a query of select all from the Titanic features. This is for the Titanic database from Kaggle, and where their name is like, instead of putting the specific name in the wildcard there, I just put with these curly brackets family name, and I created a Python function. And then when you call the Python function search family, you give it an argument, and that argument is family name. So here we have family name equals fortune, and it'll just run that query and plug fortune into here. I have a few other examples with different names, but it's a pretty cool, relatively new feature to make your queries more dynamic if you're also using it with Python. Okay, and window functions, and Fleet asked me not to do this, but I can't not. This is like it's really only the last couple of years. So like the default SQLite version that comes with Google Colab, for example, is like 2.26, and it doesn't support window functions. So like only the newer versions of SQLite support it. But it pretty much allows you to do a lot of what we would do with like many levels of joins and nested queries with like a single line. And it makes sense from like a business standpoint that you would look at things like this. Like you want to look at fare by cabin and age, rank, and all these things. And window functions create a view that you then work in. What separates them from other SQL queries is the over clause, like the word over. And it's kind of like grouping, except you see here, these are like aggregate functions, like without window functions, like average, sum, etc. And it turns it into one row. With window functions, it doesn't do that. It doesn't combine rows, so it creates duplications. And I know I'm going really fast, but it's on purpose. I'm not like, I didn't intend to go into any depth with this. I'd be happy to offline, and again, I'll share the resources and the links in the notebooks. And these are the basic window functions. Like the one you can really focus on is partition by. So I'll just give you this example here, where if I did sum fare, without any window functions, then I'd get the sum, I'd get one single line of the sum of all the fares, right? And it's like 15,000 something. If I do sum fare over, with just and close the parentheses, I would get the same sum, except it would output it in every row. Okay, so it allows me to still show other things and group by other things. Partition by is like a group by, and so I'm partitioning by cabin. The cabin numbers are here, and these are all different, but these G6 or whatever are the same. And I'm ordering by age, which you can do within your partition, and that happens here. These are the same cabin, and it starts with the oldest to the youngest. And by doing that, it's giving you the sum of the fare by cabin, and because I order, it also does it in a way that adds it cumulatively. So in other queries that I'll show you, like the sum for the fare for cabin G6 is 54. But here it's adding them one by one with a cumulative tally. So I know this is probably overwhelming, but I just wanted to expose you to it really quickly. And again, there's a lot more where that came from, and I'd be happy to share more with you when the time comes. Okay. Everybody ready to rock? That was a little much, I know. Yeah. By cabin is a column. Yeah. Like it's when you group by or partition by, what it's doing is combining rows, whether it's actually squishing the rows or not. It's analyzing a combination of rows that have the same value. And a string can equal a string, and a date can equal a date, and a number can equal a number. If you want, I can show you. Yeah, okay. It's probably best we move on. But I'm happy to talk about it more whenever you want, because it's really cool, and there's a lot of other commands that you can do with the window functions, like automatically ranking things and first values, applying aggregate functions within those partitions. And it's just like a very real world, sensible, like intuitive way to analyze data without like doing a lot of layers of joins and things like that. Yeah. No, no. So this third line here and the diagram, it doesn't combine rows when you do partition. So you could end up with duplicates, but you still get the aggregate values or the average fare for that partition or that group, but it'll just show it, many times instead of just once with a group by or an aggregate function. Yeah, I encourage you to check out some of the links and the notebooks and just play with it and get familiar with it, because it's like again, it's an intuitive and pretty straightforward way to do it, and it's powerful. You can do a lot with it in a way that like lines up with how you'd analyze things from a business standpoint. Okay, so I want to spend most of the time on examples, so this is really going to be quick. We just have a list of a lot of the crap that we covered this semester. We didn't get to some of the other stuff, but we got to plenty. And this is probably not totally exhaustive, but we don't need to spend any time there. It's just so you have it in one place. I also have in one of the last slides, I have a slide with a bunch of links, and a few of those links have like a link to a cheat sheet where I don't know if you guys have seen them online, but it's like a 1-page or a 2-page cheat sheet that has like every command that you can think of and what it does, and just so you have it in one place. There's an endless amount of resources. Okay, so I just wanted to hammer this home because it came up quite a bit in the tutorials and in the homeworks and stuff. So just hammering home on writing queries and best practices. It doesn't really matter like if every space is exactly how I said it, it ought to be. The key point is making it readable and conforming to your organization or however people around you do it, above you, below you, around you, whatever, and focusing on the output, which again is intuitive. And if you're asking a business question like how many customers came from this place before they got an ad campaign, think about what you want the output to look like. If you're asking that question, or if you're presenting that analysis to management, what are they going to want to see that gives them the answer in a clear way? And then when you run the query, make sure that the output looks like what you thought it should look like. So that's kind of just the point there. And it's for other people, it's for graders, bosses, employees, team members, and it's for yourself when you go back later on. And when you write longer queries, the easier you make it to kind of like, understand, just the more usable it'll be. Otherwise, you have to do it all over again. And I have the query execution order again. We've gone over that a lot of times. I just have it there, so it's there in one place. Okay, so this is all the links, and we'll go into examples. There are others. I'll actually add a few more and repost the slides. But here you have like a really good short video on joins, all you could ever want to know about joins. These are the two cheat sheets I mentioned. They're both pretty short and comprehensive. Oh, this is a repeat. There should be 4 different ones, but those are all in case when, and there's a lot of really good examples of different ways to do it, and it's really useful. There are a lot of situations where we need to do if-thens to split our logic of our analysis, so keep that in mind. And dynamic queries, there's some more there, and I'll share the worksheets with you too. Okay, let's do some examples. No question, sorry. Yeah, yeah, we can. Although I would tell you, like, I think when we did it in the slides, I had it in parentheses because, like, it's almost like never used. It's more just like for fun and for exercises. Um, okay. Uh, it's like tertiary, and I can do it with you after too. The idea of group concat is like when you do a group by, and there's a lot of like a lot of rows within that group that you're not seeing, and you want to see the values for all those. So like if you're grouping by album and you're getting the average length for the album, but you want to see there's like 10 tracks in that album. And when you do the group by, you'll just see the album row. Yeah. So you didn't mean like you didn't get it. You meant you just kind of like couldn't like it didn't work in the queries. Okay. Yeah, I can sit with you after too. All right, let's do some exam goals. Okay, so I have some case whens here. Okay. Then I have a bunch of queries on the movie database. So let's actually start with that. And I'm just going to erase these so we can do them together. Okay, I'll just zoom in. So I want to write them with you. Instead of just dumping a bunch of queries, we can think through it together. Okay, that's good enough. Okay. Control zoom, nice. Okay, is it big enough? Okay, so how do I get rid of this shit? Okay, let me just give you guys a. This Zoom doesn't work on this, just on the execute. Just give you like we're not going to do a ton of examples on this database, but I just wanted to change it up a little bit. So this is, it's called like the SQL database or something like that. And it's about actors and films and movies. So you have a bunch of tables. I'll also make this database available if you guys want to query it for practice. You have actors and their information, you have customers, you have films and inventory and rentals and stores and yada yada. You're not going to have to know all that in real time, don't worry. Okay, so for each employee, list the number of customers that it supports. So it should probably be he or she supports. Okay, so we have, what are the names of these tables? Okay, we have employees. Oh no, these are the two questions that I have that aren't. Hold on. Okay, it starts here, the film ones. So these ones are in Chinook. We'll come back to those. Okay, let's have a look at the film table. Okay, so these are just basic aggregate functions. Just to review, so we have a film table, which is this, and I'll tell you the names of the columns and all that, but we want the minimum and maximum lengths for a movie in each rating category. Okay, so let's start by select, and start with select, and we want the lengths, but we want in each rating category. So let's also select the rating. Okay. We start the next line with the comma instead of that line, just because it's easier to read after and to debug. If anybody has suggestions for what to fill in, just shout it out. Otherwise, I'll just keep going. We want the minimum and maximum lengths. Okay, so how about min length and max length? Right? So let's start with just doing it for PG. Okay, so the table is film. From film, we want to take it from the film table. And instead of doing it for each one right now, let's just do it. How would we do it just from the PG rating? There you go. See what we get. I don't think I can zoom on the output. Yeah, but we got 46 minutes and 185 minutes. See, because it's one single line for the aggregate function. All right, now let's try to do it grouping. So group by 1, yeah, or 1, which is the order appears in the selection, and group by 1, and what should we order it by? What should we sort by? What should we sort? Yeah, you guys tell me. So this came up a lot in the homeworks. This is like a bit of a different example because we also have a minimum, and we don't have like we're not like counting or summing. But almost always when you're counting or summing something, like if you're running a business and you want to know how many customers are in each region, or, something like that, or how many customers were added in this time period or this time period. Yeah, you care about the stuff that's biggest first, that's most impactful. So when you're looking at totals, count, sum, whatever, you almost always want to order by descending. Order by 3 descending. Let's see what we get. Okay, so it looks like they all have just about the same max, and the minimums are a little bit different. So the range isn't that crazy. And we have NC-17 movies here, if you guys can see that small. Okay, let's move on. And what if we wanted to count the number of movies that are in each category? Count something. Let's see what we have in that table. We can go back to Chinook in a little bit, just so you guys, it doesn't add that element of unfamiliarity. But we have titles, for example. We have film ID that we could count. We could also probably just do count star. But let's do select rating. Let's see what we get for doing different versions. Count star, count film ID, I think that's what it's called. Yeah. Okay. And from film. You guys can all still see, right? Wonderful. Group by 1, and let's order by 2. Okay, so it looks like we don't really have any nulls. That's the only reason why this would be different. Let's actually also do add distinct in case we have repeats. So we would do that in here, like so. Let's order by 4. Anybody isn't clear on something or wants to spend more time on something else, just shout it out. Sorry? Well, yeah, we could remove at least 2 of those columns. I was just doing it to kind of compare the output between the different counts that we covered. We definitely don't need them all, but they're not, in this case, they're redundant, but they're not necessarily redundant because you could have had a lot of repeats for some column, and in that case, count film ID would give you, like, count all the repeats, and count distinct would be a totally different number. So, okay. Just do 1 or 2 more here on movies. Okay, and then we'll move on to, we have like a little bit of a join going on here, and then we'll move on to some examples from Chinook. Okay, so the total amount of movies held in inventory, and so we're going to need the film, which has, it's like the tracks table pretty much in Chinook. We're going to need film, and we're asking about inventory, so we have this inventory table. It has film ID. So when we think about asking questions like this, as I said in one of the previous tutorials, like the first thing in the execution order and the first thing you want to think about is what table do I need to get this answer from, or tables, you know? So you'll think about what single table, and if it's multiple tables that are required to get the things that you need for the question, then think about how do you join them and in what order, and left join or join. And a lot of you in exercise 3 and 4 used, I would say, overused left joins. Like in most instances, unless you want to count something where that value doesn't exist in another table, like where you have nulls or where it might not match, like in a lot of cases where you're doing joins, it's like the standard join or inner join is more useful. And even if you get the same answer, the danger of using an outer join, like left join, is that when you then count, you could be counting a bunch of null rows that are not part of the question and shouldn't be counted. So that's the significance there. All right, so we'll use inventory and film, and we want the number of movies in each category, and we got in each rating category that are sitting in inventory. Okay, so select rating, count all. Sorry. Well, why don't we join the tables first? We could go back. So so we need inventory and we need film. So let's do from inventory, and we'll do join. Using table aliases. A lot of you guys use column aliases. Using table aliases is really helpful. When you're doing group by or referring to it later in the table or going back to it, it's really kind of standard practice, and you don't even need the as there. So you just do the table name, just where you do the from. You do the table name and the alias. Usually like 1 letter is good for aliases for tables, because it's just easier to refer to. It's very useful. Okay, so we're going to join film F. On. What do you guys think? Remember so when you join, think about the question and what they have in common. Yeah, so in this case, film ID is the only thing that they share. We could even do a natural join in that case without the on, but we won't do that. So where I film ID equal F film ID, okay? And we want in each category again, so we'll group by one like before, and we'll figure out the sorting after. So let's go back to the select. What do you guys think? We need to count something. So we want the total number of movies in each category held in inventory, right? So the inventory table gives you the film ID. See, and there's some repeats. It has an inventory ID and a store ID. So if you're looking at the total number of different movies versus the total number of like discs, it would be a different answer because you had a lot of repeats. So let's try count all, like Arca suggested. And let's order by that. Okay, so we just do 2. Let's see what we get. Okay, so we got, yes. In each rating category. So without that, we would be grouping them. So look, I can take that out. Group by rating, I dot rating, F dot rating. Okay, and then order by 1. We should get the same table. Yep, we did. We got the same output, but now we have no idea what. So like what I was saying before about thinking about how your output looks, like this is the right answer, right? But like, what the hell does that tell me? Like it's just a bunch of numbers. And if I'm doing something by names or employees, if I just have their first name and there's like 10 Bobs, then I can't really do anything with it. You want to think about it from the standpoint of why you're asking the question and how you're going to use it, and if you can use it when it looks like this. And the same goes the other way. So if you do, select all, then it's going to be a mess, and this is technically correct, but like, I don't know how to read this, and most people have a really short attention span. Okay, so when we did count all, that's what we got, like this. And now let's do count distinct I.film ID. And let's actually put them together so we can compare. Okay, and we'll order by 2. Okay, so we got a very different answer. So, and sorry, I can't zoom on the output. Sue me. We have like 200 something, and we have 1,000 there. As you saw in the table, there were a lot of repeats for the film ID. So, okay, we'll do one more. Okay, which movies of rating PG are held in the highest quantity? So we hold the store, the rental company. I know this is like probably before your time, but there used to be like movie rentals, Blockbuster Video, and then Netflix started actually as a company that was like sending the tapes or the DVDs like by mail, which was like really inventive. That's how Netflix became Netflix. And then Reed Hastings said, people aren't going to watch in these machines anymore. They're going to watch on the internet. So they pivoted. It became what they are now. But this is like a rental, film rental thing, and they hold certain amount of movies in inventory, and they want to know, like, out of the PG movies, what movie do we hold like the most of? And you might want to know if that matches up with demand, because inventory has a cost, and you don't want to hold a ton of excess inventory that's, you know, of movies that are not popular anymore. So I have overdue rentals there. I don't know why, but let's first do that one. Okay. So I mean, it's really not so different than the last one we did. Yeah, I was just debating whether to keep going with it or not. Okay, so let's select the rating film ID from which one? We'll do i.film ID. Let's copy our join. What else? Count max. Okay. Max what? Why, and why do we want to count? For each group, yeah. It'll give us for each group though. So what do we want to count the max of? Can't just count max. Max, like, is a maximum of something. Like, but you want to count it again? Like, so it's saying which are are held the highest in inventory. So we have like the inventory ID here, which I guess is like the quantity. You would just, so you want to count those, you're saying. Okay, let's try. So we want to count the maximum of the count of inventory ID. Okay. The max of inventory ID, but inventory ID is just a number. So there's like, 500 IDs. It's not counting. It's not counting the rows. Okay, we could try it. I have another suggestion. Let's try this first. ID. Okay. As highest quantity. Okay. Film. We're going to group by rating again. Right? Oh no. Which movies of rating PG? Okay, so in this case, we don't want to group by rating, because we want to count the number of inventories for each title. So so let's group by F dot title. Group by 3, which is the title from the films table, and let's order by the max count. Let's see what we get from that. Oh, yeah. Nice catch. Where rating equals PG, right? Is that good? Uh-oh. Errors. So let me tell you what I suggest. if we just do the count, and we could do like the, we could really do count all of them because we're grouping by the no, I don't think so. Let's see. No, they're just going to be repeated because we have it's going to be matched to the film ID. Let's see what happens. Boom. Okay, so we could have grouped by film ID also, but in the joined table, it matches the ID to the title from the film table. So where you had a bunch of repeated IDs, they're just going to repeat the title and it's going to group like that. So here we have a descending count of all movies that are PG and their film ID and the title of the movie and how many of those we have. All right, let's do, wow, time flies when you're having fun. So I want to do a few. But how would you know? How would you know? Because you have a bunch of rows that are the same, like the title and the film ID, and you want to count the number of times you have each movie. Because they have like 10 copies of Frozen in inventory, you know? And that's what we're trying to find out. Like, which titles do we have the most in inventory of by title? So we have to group by title so that we could do the aggregate for that same value. Yeah. That's exactly what we're trying to count. Okay, so I'm going to go back to a few examples and we can go a little bit over until I get kicked out or told to leave. But I just thought I'd show you my last few cartoon slides. Good luck on the exam and great luck in life. A few SQL jokes. And my dancing guy again. A few more SQL jokes. And okay, so I have examples. I think what I'm going to do is keep blabbering and keep doing the examples in real time while you guys coming up to get your gifts. Okay, let me do an example on Chinook first. Come on, Camilla, don't be a party pooper. I even unzipped it already. I'm so excited. Okay, all right. Okay, Chinook, what is the total number of tracks sold by each artist in each country? In countries where the artist has sold more than 100 tracks in total. Okay, so you guys know all these tables. We don't have to browse the data. Total number of tracks sold by each artist in each country where those artists have sold more than 100 tracks. All right, select. Should we do our joins first? So we want to think about this. we want to know the number of tracks each artist sold in each country, right? And then we're going to cut it off for artists that have only sold so much. So what table or tables do we want to create and join to query from, right? So we need total number of tracks. So we need something about tracks, track ID, something. We need artist, not composer, right? We need sales in each country, right? So something with customers and invoices, because we get the country from customers and we get the like number of orders from invoices. Okay, so we got 4 tables. Now let's slap them together. And then I'll do a left join one, and then we'll have more fun. Oh, I didn't expand it. Thank you. I was just laughing because like there's like this scene in Friends, the show Friends, where like he doesn't tell him to like shut up. He's like, and Camilla's like, this unspoken, make it bigger. How's that? Cool? Okay. So let's slap the tables together. We need our invoice lines, right? Invoice. Oh, I need to open that. One sec. Chinook. There you are. Okay. Invoice. Oh, come on. Open database. Oh, yeah. All right. Let me try it again. One sec. Close database. That's what I get for trying to make it a little more interesting for you guys. Instead of just being on Chinook. There we go. There's our old friend. Okay. So invoice items or line ID. Do invoice line ID. Right? Invoice items. That gives us the number. Yeah, the line ID. Okay. So invoice items. And we'll call those I. Join. What else do we need? We need customers, right? Customers C on I dot invoice ID equals C dot invoice ID. Join. What's the next one? We need tracks, right? Tracks T on track ID. Is that in invoices? Yeah. Okay. On I dot track ID equals T dot track ID. Everybody following? Sorry? Customers. Customer ID. Invoices okay, sorry. So invoice lines on invoices, and then it's in invoices that we join to customers. So let me do that. Invoices join. Customer ID is going to be from invoice items, I think, to no, I did it the other way around. Join invoices. Hi. We'll just do it all in one thing, and that'll be like this. I.invoice ID equals I.invoice ID. Okay, then we'll join customers on I. It's in invoices, you said, right? Is the customer ID? Yep. Okay, so I dot customer ID equals seed customer ID, nice catch. Okay, join tracks on that. We need artists, right? And we need albums. Wow, this is a pretty convoluted question. Albums A or Al. It's going to be with tracks equals Al, the album ID, join artists. A on, that's going to be with albums, right? Yeah. Okay, so we got our table. Remember, we want the total number of tracks sold by each artist in each country. So we'll come back to the select. Let's group by, we want by each artist, right? So we got the artist table. So let's do a.name. All right, that's the artist. We're going to group by that. And we want it by each country. So we're going to have a secondary group and the country comes from the customers table. So we'll do c.country. Okay. And the invoice items is the one that has the invoice line ID. Having some, we could also count the IDs, but we'll just do II dot, we can have the quantity, yeah, greater than 100. And we'll order by, we're tracks related to that. So we'll order by, all right, let's figure out what to select first. Okay, so we want the artist name, we want the country, we want the number of tracks sold. So let's do a name as artist. We'll do c.country as país. And we'll do what we did at the bottom there, which is quantity as total tracks, or number of tracks, tracks sold. Okay, and we'll order by 3 descending, and then let's do artists second in ascending order. Let's see what we get. That took quite some time. I'll do a shorter one next, and then the rest will just be, oh, this is why. I forgot to comment this out. Oh. I could do group by 1, 2 also. The mistakes happen when you go by the names. That's why it's good to use the numbers. Okay. And if it's still an error, then I'll come back to it. So I want to do a join example. Okay. I will fix it momentarily, but that's that should give us the right output. I just want to do one with left joins to show you guys the difference. So I have let's do this example 10. Okay. Yeah. I have have a note about joins, and I'll share all this with you guys after. So the average track price for each genre in each week, where the average track price is greater than $1, and the genre has been sold in the past month. Okay, so we're looking at the sales of these records. We're a record store or whatever, a music store, and we want to know if they've been sold in the past month, and they sell for more than $1. What's the average price by genre, and how is our pricing? Like if we want to evaluate pricing trends in the business by genre, and where there's more price competition, where we have to do more discounting, et cetera. Okay, so I'll just write this one out. Save us some time. The genre name. And we want the week, right? So string from time. Invoice date. This is invoice date. Yeah. Okay. As week. I'm almost done, guys. Average. We want the average unit price. We'll take that as average price. Okay. Tracks T. Let's join to genres. G. They share the genre ID. Okay, and now we may have some tracks that weren't sold, and we want to capture that because we only want the ones that were sold. So we want to get every row, even if there are lines in the other table that don't have a value. We still want those lines from the main table, because if we did a join and there was no value in the sales for this week, it wouldn't be in the common join table, right? Because if there are nulls, it wouldn't be there. But if we want to get all the tracks and we want to know if it was sold or not, and if there was a case where it wasn't sold in the past week, which is a condition here, then we want to do a left join because we want to get all those rows in tracks, and we want to know that there is a null value in the sales from the other table. So that's an example where we use a left join. Also, the example of the real estate customers and properties I gave you, where we have properties that are listed that haven't had any customers come to see them, or vice versa. That's where you'd use an outer join. Otherwise, most of the time, an inner join makes more sense. So this SQLite only supports left outer joins. So we'll do invoice lines, invoice items, and that shares the track ID. Okay, and then we want the invoice ID from invoices and invoice lines to match up. Okay, we're doing it by genre. That's what the question is asking, and we're doing it in each week. So for each genre, we're going to have also a secondary grouping of the weeks, which is what we did up here. So I'll I'll just replicate that. Okay, I hope you guys can follow and that it's big enough. Okay, I'll just leave it at that. Oh, unit price is T. I didn't put. There we go. Okay, so in the output here, maybe I can do this. So you guys can see. Excellent. So we got our genre. Here are the different weeks. Here's the average price for that week. We didn't use the cutoff. Oh, I didn't do having. Un momento. And add. That was one of our conditions. Having, we said where the average track price is more than $1. So having average T dot unit price is more than 1. And what was the second condition? The genre has been sold. Genre has been sold in the past month. So and minus 1 more. I have so many queries and examples to go through with you guys, and the time just got away from us. If only we could have 6 more of these tutorials, right? Sorry? I have all the examples in SQL file worksheets already prepared, and I'm going to upload all that. Links, I'm happy to go over any of it with you, you know, over Zoom or at school, whatever. Just reach out to me. See, this is what we got by week, etc. Whatever. Good enough. Any questions? Yeah, I'm going to post an assignment, and I'm going to try to make it. I'm going to try to make it like be as kind of like an exam prep. So it won't be on like one specific subject. I'll make it clear which types of commands to use. It'll like borrow from past exams so that it will mimic the like exam format and content. You can have as much time as you want. Yeah. I'm not sure the exact date. I'll just ask a fleet, but you'll have more than a week. Did everybody see my note on Moodle or the email? Just be sure to submit your own work. Like I'm taking 4 classes. I'm a student too. Like I work with my friends all the time. Sometimes I even like copy a question from them, and like there's nothing wrong with that. But just submit your own work and change it up. Make sure that you understand the query. Don't just pass around copy and paste things, because it won't be graded. And frankly, I think that's kind of a light consequence. But I sent an email about it. Just keep that in mind and respect the honor code. And if you need help on anything, if you're stuck on anything, reach out to me. If you're unsure about anything, just let me know. I'd be glad to help. All right, so thanks everyone. Now, hopefully end on a good note. I got to look back on this time. This time of me, and just smile for the rest of your life. SQL teachers. Yeah, there's different sizes, so I'll sort them. SQL order by group by size, order by to descending. There's there's men and women sizes. They're not all the same. It's kind of like a variety. Yeah, let me check which ones are female sizes, because those are split by size but not by gender. Hold on. Wait, I want to make sure that the guys don't get the like the female cut. I mean, unless you want that, which is cool too. But. Okay, here we are. Okay, view order. No. Come on. Wait, I'll let you guys know about the cuts. I should have checked that before. Yeah, pleasure. I hope you guys enjoy. Why is Amazon not working? Okay. Um, all right, I can tell you guys which the female ones are. Um, so there's two of these in medium, and then the one with the crown. Uh, no, you got a male one. There's two medium female ones for the medium for that. Um, the ones with the circle are female. Yeah, so you're good. And no, I think you're okay. Yeah, if it fits, I think you're okay. Yeah, it's a pleasure. No, thank you. Thank you. Oh, good luck with everything. Okay, and then there's the one with like there's two female larges. Oh, okay, excited. What would I do that for you? No, it is. It is. No, it's also large, but it's also like users or Did everybody get one? What did you choose? Let's see. Which one?